Hello, welcome everyone for this system design question. Today we are going to design a push notification system. We are told that this is an e-commerce company and delivers more than 1 billion notifications per day. 1 billion indicates that this problem is really about scale. It comes to around 12K notifications per second. We are also told that the notifications could be delivered to Android, iOS, and email. As usual, when it comes to system design, ask the interviewer to give you few seconds to read and think about the problem. Once you read it carefully, proceed to asking more questions. Generally, interviewers expect you to ask some questions and they deliberately leave some things ambiguous in the question. You should thoroughly examine the problem statement to detect such ambiguity and ask interviewer to clarify it. One simple technique is to ask interviewer about some critical journeys. What are some examples of a notification? How are we creating these notifications? Are they targeted at group or individual? What about preventing spam or ensuring that we do not send more than necessary notifications to the user? Once you have answers to all these questions and more, you should proceed to approach the problem. In this particular case, 1 billion notification tells you that this problem is really about massive scale. Even if we assume 10 kb of data per notification, it results into 100 gigabyte data per day and 12,000 notifications processed per second. Such systems should be horizontally scalable and loosely decoupled so that they can be individually developed, deployed, scaled, and monitored. So one strategy to attack such problem is to always come up with a super high level design first, and then proceed to the low level details one component at a time. Tell interviewer your plan. Always tell the interviewer what your plan is. Then proceed with the plan. Do not talk without giving full context to the interviewer. A good plan is always to enumerate some functional requirements, some non-functional requirements, then a very high level design, and then drill down for more details of the design. We can focus on any one component in low-level design. Having said that, let us look at functional requirements. Make sure your interviewer agrees with the list of requirements. Functional requirements is about the features of the system. Based on the problem statement, we outline the following functional requirements. We need an interface for various teams to create their notification campaigns. This will consist of an internal application which we call campaign management. It will consist of a simple CRUD-like interface to relational database, which is responsible for storing the campaign metadata. This system will also be responsible for template design and management. Once templates are designed, they can be sent for localization. Campaign management system will let team members decide the targeting criteria, nature of notification, scheduled or real time, and set any policies such as max number of notifications to be sent. We will also have a user system where individual users' notification preferences will be stored. These are the very crude functional requirements for now. Since the system is complex, the real requirements will be driven by different product teams. For example, we will have some notifications for order information, some for marketing purposes, some for authentication, some for product delivery, etc. We have to build a generic system to meet all such use cases, so some of the requirements are kept deliberately vague. In non-functional requirements, we are looking at the infra requirements. 1B notifications per day means around 100 gigabyte data generation per day, assuming 10 kilobyte of payload per notification. It also means around 12K notifications per second. This is just average. The peak load will be higher and could be, say, 5x of normal load. For the sake of design, we define three types of notification SLOs. Critical, which is meant for absolute real-time delivery. This could be notifications related to authentication, payments, OTPs, etc. We define it as within 30 seconds of delivery. Similarly, real time is defined as 30 minutes of intended time. This could be delivery notifications, updates about product information change, etc. The scheduled notifications SLO would be around 1 hour of target delivery. Of course, these are ballpark numbers we have just assumed. In reality, we might have to provision different types of resources to make these numbers a reality. Since our storage is also growing linearly with time, I think we need to regularly prune our database and move data from our database to a long term storage like Amazon S3. Once notifications are delivered, they are not really needed to be stored for long. We only need their storage for the purpose of checking any policy restrictions and dashboards. We can prune database, say, every 30 days. So we come to the first component of the system, the campaign management. This is going to be an independent component where team members can log in and create campaigns. It will have a template studio to design templates as well. The complexity here is in the design of the campaign, but we can refer to some of the existing tools in the market to understand how this can be done. Firebase offers one good reference. Given that this system is tangential to the core problem, I will not spend too much time designing this in detail, but if needed, we can do that. The next step in the high level design is important. Our assumption is that the campaign would target specific users who meet certain conditions which are based on their actions. We think of a queue of events called ETL pipeline. The entire system logs their events to this pipeline for all other consumers. This could be user logging in, logging out, searching, buying, product being delivered, etc. The campaigns would ultimately be using these event criteria to target users. We can also have this pipeline sharded by criticality. For example, critical events like login, etc., could have a different pipeline. Our notification reader pool is a collection of workers that read from this pool. We might want to shard them by user id, so same worker handles all notifications related to a user. This is important as it maintains ordering. A notification reader basically detects events of interest from the pipeline and calls a campaign evaluation service which matches the event with currently active campaigns. We are talking about 11K per second notification generation, which means the actually possible set of events would be much higher. So this pool will have to the largest, and the primary job should be to filter out events that may not lead to notification generation. We expect the number of active campaigns to be in few hundred at any given time. So comparing against each of them is relatively simple and low compute task. Campaign Manager DB could be a relational DB, but we must add a hot cache to reduce any latencies in this operation. Entire campaign data can be loaded in memory on every reader machine if needed. Campaign Evaluation Service is the service that takes the notification and matches it with campaign data. It might additionally also call other services such as user service to check users' push notification preferences. But for the sake this design, we are avoiding that. This service does a lot of heavy lifting. It will look at the campaign user preferences, existing notifications for that user to decide what to do. If it decides that a notification is warranted, it will write to update to a database we call notification DB. For every row, the change will be written to one of the three queues. Critical queue for high importance notifications that are sent immediately with dedicated resources. Real-time queue for immediate delivery, and scheduled queue for notifications that require to be scheduled in future. The next step in our high-level design is the notification rendering system. This system reads from both critical and real-time queues. At this point, decision has already been made to send out the notification. So it looks up the campaign DB to fetch the templates and call all the microservices that feed the data to generate the template text. For example, this campaign could be about price drop in the product user had added to their cart. So the rendering service might have to fetch the current product price, user info, product images et.c to generate the notification and email. Notifications such as emails will also contain call to action items. Clicks on such need to be detected too. Hence, the URLs need to have such parameters. It is also possible to do A/B tests with different templates here, so rendering logic might change depending on the user ID. All that complexity is handled by this microservice. Once rendering is complete, it adds the final payload to the delivery queue. It is possible that rendering might fail. Maybe the product is no longer available. Maybe the user opted out of notifications. In all these cases, the rendering fails, and the service might add this entry to a dead letter queue where it might be analyzed by developers. Once a notification is added to the delivery queue, it is pretty much set for the delivery and might not be cancelled by manual actions anymore. Before we move on to the delivery portion, we need to also design for the scheduled notification. Remember, we added such notifications to a separate queue. We have a scheduling system microservice that reads these notifications and adds them to the real time queue when they are meant to be delivered. If the scheduling is overridden or cancelled, it might also factor in those changes. How do we exactly do this? There are a number of ways to do this. We can either use standard relational DB and pool of workers that scan it every few seconds and process ready notifications. Or we can also use some of the standard delayed delivery queues for this purpose. For example, Google Cloud's Pub subsystem supports scheduling delivery to the queue at a future date. We can use that here too. Either ways, we can use some of these standard patterns for this purpose. Now let us look at the delivery queue. Once we have added a notification to delivery queue, the next step is policy cop. This acts as a final check. This service is responsible for running any last-minute checks, such as making sure we are not spamming anyone, applying any global limits. If previous steps ever introduce a bug, hopefully this service can catch it. If PolicyCop passed the final checks, it sends it to the router, who then delivers it to the platform-specific queue. Sending push notifications to iOS and Android devices involve making calls to Apple and Google. So we will have some workers doing just that. For critical notifications, we can have separate queues with dedicated workers. For emails, we can either use third-party APIs like SendGrid, or to save money, we can run our own SMTP servers. But this is the simplest part of the system. I think one of the biggest challenges is campaign design. How do we design a campaign data model that can cover all possible cases? Let us take an example. If a user searches for an item, then is inactive for 3 days, we remind the user about their search. In the campaign design, Campaign Creator will select event of interest as search from a giant list of possible events. Then select criteria as from a list of criteria as user inactive for 3 days. Then schedule the notification for 3 days later. Note that the search indicates the user is active, but the user inactive condition needs to be true only during the delivery time. So the scheduler service might check it right before it adds it to the real-time queue. For this, I propose I would like to introduce a criteria resolution service with its own database and cache. All the campaigns must specify a criteria for execution from a provided list of criteria. We can also allow them to specify multiple criteria with OR and conditions. For all real-time notifications, the criteria must be satisfied at all times, and for scheduled notifications, it should be satisfied before it gets added to the real-time queue. This service too can be slightly smarter. Depending on the caller's context, it can provide signals to cancel notifications as early as possible in the pipeline. Let me put all these different components together now. The diagram might look complex, but in reality, there are just 4 steps in the pipeline. The first is the campaign manager. Second step is the notification evaluator. Third step is rendering, and fourth is the delivery. For scheduled notifications, we simply write it to the real-time queue when the time is right. Whenever you design a system, always discuss some alternatives as well. Is there any alternative to this notification system design? One way to do this is to write all the ETL logs to a distributed storage like Amazon S3. For every campaign, create either a MapReduce job or a streaming job like Apache Spark. It continuously processes logs to generate and overwrite notifications. Converting a campaign into a MapReduce job programmatically could be a fairly complex process. There are multiple ways to do this. One way to do is the MapReduce job to scan entire user database, check if the user meets any criteria of existing campaigns, and then create notifications for the user. store the user's notification per user in a NoSQL database. Real-time notifications can be added to the real-time delivery queue right away. For scheduled notifications, every notification must be checked for validity for every run of the job and cancelled if not applicable anymore. One advantage of this approach is it is much easier to check entire history of notifications per user and also apply user-specific preferences. Also, the MapReduce jobs can be sharded based on user ID. Inactive users can be ignored. Certain users might be given higher priority, etc. Online systems are harder to maintain and require significant DevOps resources. The disadvantage is that we have a MapReduce job running continuously on the incoming logs and often reprocessing all the data multiple times. In a globally distributed system, logs might be residing across the world. It might not be possible to move them to a central region for MapReduce to run. Ultimately, the choices boil down to costs and complexity and would depend heavily on the nature of existing data, global structure, nature of campaigns, etc.
There is also no reason why we cannot build a hybrid system. It should be possible to create a mixture of both where certain jobs are ran as MapReduce job and some run through our online system depending on what works the best. Thank you for watching this video. If you have found this in-depth design useful, consider liking the video and subscribing to our channel. If you want us to cover any specific problem, we will be glad to cover it for you. Criticism is also welcome, and please leave a comment with your criticism.